Hi students, in this video I'll be going through exercise 10E question 3E. Alright, so let's read the question. So in this question we're asked to prove that 1 minus 2 cosine square x over sine x cosine x is equals to tangent x minus cotangent x. Right, so as usual, whenever you have a trigo proving question, basically what you do is you want to try to start from the side that is more complicated. Right, so for this particular question, it's quite obvious that the left-hand side is more complicated. Okay, so maybe we can try to start from there. Right, so let's try to start from the left side. Okay, so the left-hand side, we have 1 minus 2 cosine square x over sine x cosine x. Right, so this is what we have on the left-hand side now. Okay, so one clue to think about when you do this kind of trigo proving question is that you look at the right hand side. What do we have? Okay, the right hand side we have two terms, right? One is tangent x and the other one is minus cotangent x. So basically what we want to do is we want to try to split this left hand side right into two terms, and then hopefully each of the terms can simplify to tangent x and then cotangent x. So if you look at this question, if I try to split directly, this is what I'm going to get. Okay, so if I try to split directly, this is what we're going to get. Okay, if you think about this, there's really nothing much that we can do on this side. You see, tangent x is sine over cosine, but what we have now is 1 over sine x cosine x, so we can't convert it to tangent x. Then over here, if you simplify this, you actually get 2 cosine x over sine x. Okay, that will give us 2 cotangent x, but what we want is negative cotangent x, right? Okay, so this means that at this point in time, we may need to do more steps first, okay, or perform certain procedures first before we can split up this fraction. Okay, so at this point in time, you need to think about what are the identities you have. You have a 1, and then you have a minus 2 cosine square x, right? So at this point in time, for cosine square x, of course, we can replace it with 1 minus sine square x, right? Okay, but you need to think, if you were to do that, right, does it serve any purpose or not? Okay, so we know that sine square x plus cosine square x equals to 1, right? So cosine square x will be 1 minus sine square x. So I'm saying that if you replace this cosine square x with 1 minus sine square x, and you visualize when you expand out, what will you get? You will get 1 minus 2 plus 2 sine square x. So that would be almost a similar form, okay? That when you try to split up, you won't be able to get a tangent x minus cotangent x, right? So maybe that would not be a suitable substitution that we can make. Okay, but always remember, we can always make this initial substitution. Okay, use this initial identity that we have over here. We can actually replace the 1 with sine square x plus cosine square x. Okay, so let's see what will happen if we do that. So I'm going to replace the 1 with sine square x plus cosine square x minus 2 cosine square x over sine x cosine x. Okay, so at this point in time, you may be asking, hey, the expression looks even more complicated now. Okay, so what purpose does it serve? Okay, but if you look here, we have sine square x. Cosine square x minus 2 cosine square x will just give us negative cosine square x. So at least I've gotten rid of that 2 over there. And what I have now is a minus. See, over here is a minus, right? Okay, so at least I've gotten rid of the 2, and then I've gotten this minus 1 over here, this minus. Okay, at this point in time, you think, can I split this up now or not? Yes, okay, splitting it up now will be much easier to simplify, because now you will just have sine square x over sine x minus cosine square x over here there's a cosine x over sine x cosine x. And if we were to cancel one sine x from this left side, okay, so sine square x over sine x will just be left with sine x over cosine x, and same thing, we'll cancel one of the cosine. Okay, we'll be left with cosine x over sine x. Okay, and indeed, this will give us what we need to show. Sine x over cosine x will be tangent x minus cotangent x. Okay, and this will allow us to arrive at the right hand side. Right, so for this question, okay, use identity at the start, okay, then simplify the top first before we split up. Okay, but some of you may think that actually this is a rather complicated method, right? Correct? Not easy to think of this. Okay, but for this question, okay, actually going from the right hand side will be a viable option also, although the right hand side is the simpler looking side. Okay, so let's try to go from the right hand side now and see what's the difference. And how come for this question, right? We can actually choose to go from the right hand side, although the right hand side is the simpler side. Okay, so you see over here on the left side, all the terms are in terms of sine and cosine, right? And on the right side, we have tangent and cotangent. So we should be thinking about whether we can convert a tangent, right, in terms of sine and cosine. We can do that easily because tangent is sine x over cosine x, and then cotangent will be the other way around, cosine x over sine x. Okay, so why can we use this method now? Because actually now what we need to do is on the left side is just one single fraction, right? So for the right side, all we need to do is just combine these fractions together, and we can do that easily. So by making a common denominator, so if we were to make the denominator sine x cosine x, then over here we will have sine square x, then sine x cosine x, then minus cosine square x over sine x cosine x. Right, then if we combine them together, we will get this. Okay, so we have almost there already. Okay, then basically what we need to do is you look at over here, it's only in terms of cosine, right? Okay, so basically what we want to do is we want to sub away the sine square x, right? So we'll start from this identity again. Okay, sine square plus cosine square x equals to 1. So I'm going to bring the cosine square x over, so I get this. Then I'm going to replace it inside. Okay, so I'll get 1 minus cosine square x minus cosine square x over sine x cosine x. Okay, so that will give us 1 minus 2 cosine square x over sine x cosine x, which is what they want us to show on the left side. Okay, so in this question, we see that both methods are viable, whether you start from the left side or the right side. Okay, so it depends on which method you think it will be better for you. So for the right side, it's easier to just combine two separate fractions and to split them up. Okay, for the left side, you got to be able to see the identities, the correct identity to use. All right.